activity I hope you guys were able to use yesterday. I will watch the video in just a second, Vince. Uh, we're going to do the elaborate activity together. I hope you guys got a chance to finish up the notes from yesterday and or watch the video recap that I posted for you guys, going over the notes. If you hadn't done that yet, I highly recommend going through that. Tomorrow with your mid-unit quiz, I will go through at the beginning of class and do a big review. So if there's any concepts that you are like, I still don't feel really comfortable with this one, be sure to be jotting those down or highlighting them in your notebook and making sure you let me know so that we can go through those before your quiz. But basically tomorrow we'll do a quick review and then take your quiz, and then it is spring break, people. Get excited. Oh, it's gonna be glorious. And then you come back and we have 1 week. I don't think you guys realize, like, if you guys have looked at a calendar lately, but we get back and we finish this quarter and then we've got 2 weeks to start fourth quarter and then we're already in May. Like, it's just gonna fly by. It's gonna be so crazy, but we're almost there. We've got 7 days left of third quarter. So our big focus for today is going to be looking at trophic cascades. If you remember back to our very first activity that we did where you got to watch the video about the starfish and how the starfish impacted the ecosystem, you were actually looking at a trophic cascade. In your notes section, when we were looking at the food web, the marine food web with the shark, and it asked you, okay, what would happen if we removed the shark? How would that impact the ecosystem? What you were looking at was an example of a trophic cascade. The STEM gizmo that you guys did, you were looking at examples of trophic cascades, okay? So now is the time we're actually gonna go through it with a little bit more of a fine-tooth comb, and really start to be able to determine the effects of what happens when we start to mess with top predators, okay, in their food chains, and how does adjusting the top predator in one food chain affect the whole stability of the ecosystem, okay? So for this one, we're gonna be using an interactive, and in the interactive, they use a couple of different symbols that aren't necessarily super intuitive. So I wanted to walk through the first part of it with you guys, make sure that we're all on the right track. And then there's 4 additional case studies you guys are going to do. I'll do the first one with you, and then you'll get the rest of the class period to wrap up the three remaining ones. Okay. So the interactive is posted in Google Classroom. Now I'm going to be using it on my screen and sharing it. So it's totally up to you if you want to pull it up right now. So you have it on yours, or if you want to wait until you go off on your own to then open it, so you're not bouncing back and forth and you can just watch mine. The choice is totally up to you, okay? But in our notebook, the slides that we're going to be working on are slides 10 through 12 today, okay? So 10 through 12. There are 3 major sections to the activity. So you have your introduction, you have the kelp example, and then you have, starting on slide 11, your 4 case studies. So you're going to be looking at one that involves the Arctic tundra, second, the Midwestern lake, the third is an African savanna, and the fourth would be a Venezuelan jungle. Okay. So without further ado, when we go into Google Classroom, that's what's linked right here. Again, I apologize. Actually, this is second period. Your due date for this one, it's not an actual assignment that you need to turn anything in for besides stuff in your notebook. And it is actually not due last week. So if it said you had a missing assignment, I'm totally apologize. I just goofed and hit the wrong date. So once you guys, I reopen that up, you guys are going to click, you would click on the link, and it's going to take you to this site, okay, the Bio Interactive site. Once you're there, you're going to then select Launch Interactive. Now, it'll naturally put you into a separate window. If you don't like that, remember, you can always right-click it and tell it to open the link in a new tab. And that way you can just bounce back and forth between your tabs, okay? So the first thing we're going to do is going to be looking at this introduction piece, okay? So kind of following along here. So ecosystems are comprised of a community of organisms and their physical environment. Ecologists study the interactions among these organisms and the factors that affect organisms' distribution. The structure of an ecosystem can be represented by a pyramid made up of what we call trophic levels, such that the producers are on the bottom, followed by primary consumers and secondary consumers, and so on. This click and learn illustrates examples of what can happen when the top of a pyramid changes. How are the levels below affected, and how does the ecosystem change? Okay, so this pyramid right here is a simple trophic pyramid from the coastal Pacific Ocean, which shows the kelp forest that is eaten by sea urchins, which are then eaten by sea otters. Okay, now remember, when we're looking at ecosystems, the term eco, if you watch my notes recap, the prefix eco means house. Okay, when we talk about systems, we're really looking at what is going on, or what are the functions that take place. So really, these are what's happening inside the house. We can use the term ecosystem, and I could apply to our literal homes. So what's happening in my home and the distribution of the living things in my home. So how many females, how many animals, how many males would look different than your home, which would look different than John's home, which would look different from Ben's home. Okay, so every ecosystem is going to be different in both size, complexity, and arrangement. Okay, the parameters, or when we're talking about how large of an ecosystem we're going to look at, really has to do with the person describing it. Okay, we can also consider like Auburn Riverside to be an example of an ecosystem. Okay, where each different grade level would be considered its own population. Okay, and remember, ecosystems are a collection of lots of different populations that make a community. And Riverside is a community. So you could say we have the freshmen, we have sophomores, we have juniors, we have seniors. On top of that, we have all different types of staff members. We have teachers, you have custodial staff, you have administrators, you have counselors. All of these populations work together to ensure the stability and basically the success of an ecosystem. Okay, nature is no different. It has to have balance. And sometimes when you mess with different parts or different components of that ecosystem, so different populations change, it can have some pretty drastic impacts on the whole. Okay, so think of like if we were to look at the school. Okay, now some populations are more important than others, okay, in the effect that they could have. So when we are thinking about, let's say, students versus staff, there are a lot of students. If we were in the building this year, oh my goodness, our student population is close to 1,800. That is insane, 1,800. We certainly do not have 1,800 staff members, okay? We are sitting right around 200. So now think about it though. When everybody is all in the building, you have 200 staff members versus 1,800 students, everything goes well, relatively speaking, okay? The balance, the harmony in the ecosystem of the school is working well. Now, what would happen if we took out the teachers or the staff member altogether? What do you think would happen?
Don't know.
Just think about it. Just like envision that for a second. You're like, I'm in school. All of a sudden, you remove all of the staff members. So in the chat, like, what do you think would happen?
No knowledge.
I think, Victoria, you're nailing it right on the head here. Like, utter chaos, right? All I can think about, have you guys seen that? Have you seen the movie Mean Girls? Is that too, like, old? I mean, it's kind of on TV. Okay. The scene in the lunchroom, like, where they all start attacking each other because she's envisioning, like, what it looks like in the African savannah in the lunchroom. That's all I think about when I'm like, if you removed all of the teachers, that is exactly what it'd be like. Some people would be in the corner just like, what is happening? Others would be like savages. Like, it would be utter chaos, like straight up Lord of the Flies chaos. Now think about the difference though in the size of the population. There's only 200 staff members. There's 1,800 students. So when you talk about how the role or the importance of the staff member in that ecosystem, they would be like a keystone species in this case, much like a top predator, okay? And that's what we're gonna look at today. So what happens when we start manipulating and changing the guys at the top, okay? And this is one of the vocab concepts that were in the beginning of your notebook when we had top down versus bottom up, okay, changes. Right now, we're gonna look at top down. So what happens when we change something up here and how does that impact the rest of these levels moving down, okay? All right, so this video, I'm actually gonna skip over it because it's a segment from the very first video that you guys watched, but and I'm gonna walk you through kind of what's going on here with this population, okay? Now, when you have this ecosystem, okay, where you're looking at sea otters, then with the sea urchins, and then with the kelp, okay? The sea otters eat the sea urchins, and the sea urchins eat the kelp, okay? So what that you're describing here is an actual food chain. In this case, you're just describing it from a top-down approach as opposed to a bottom-up approach. Now, there's two different types of effects that are going to happen when you start to mess with different pieces or different levels in that chain, okay? Now, you are going to have what are called direct effects. So some changes that you make are going to directly impact some other population in the chain. So for instance, if I mess with the population, let's say I decrease the number of sea otters, okay, let's say I wiped these guys out. That would have a direct effect on the sea urchins because the sea urchins are eaten by the sea otters. So if I remove that top predator, we're going to see this massive increase in population for the sea urchins. They're going to be like living their best life. They're like, yes, we don't get eaten anymore. Okay. Now the sea urchins, because they didn't get eaten, their population increases. And that then will have a direct impact on the kelp, okay? Now, if the kelp or the sea urchins eat the kelp and there's more of these guys, then this population is going to go down. So you're gonna have direct effects, okay, on the neighboring trophic levels. However, that's not to say that we can't look at what happens from the sea otters and how they're related to the kelp. When you are analyzing something, okay, and you're looking at where we're gonna like skip levels, that is what we call an indirect effect, okay? Now, another way I could kind of describe it in like non-sciencey terms, like if we were all standing in line, like in our classroom, and it's like a domino effect. Let's say that Beyonce is gonna be standing next to me, and then Victoria is next to her, and then you're gonna have Mustafa, and we're gonna all line up. Now, what would happen if I shoved Beyonce? Okay. I only hit Beyonce. Okay, but guarantee you, if I shoved her hard enough, she's then going to bump into Victoria, and Victoria's then going to bump into Mustafa, and so on and so forth. Okay, so in the way that I would describe that, I have a direct effect on Beyonce. I hit her, I pushed her. However, I have an indirect effect on everybody else because my actions, my moves affected everybody else down the line. It's like a domino effect. Essentially, I've created a cascade. And when we're talking about trophic cascades, trophic just means feeding level. Okay, so we are messing with the amount of population, so the amount of organisms within each feeding level. Okay, by enacting some sort of change at the top. So in my case, I would be at the top in our classroom. I am the top, and I'm going to push on one of you, which then is going to cause this rippling effect throughout the whole system. Okay, does that make sense? Okay, so show like in the chat, yes, you are alive, or no, you are not. Okay, so we're gonna go to your notebook and we're gonna start coming up with some definitions. Good, my little smarty pantses. Okay, so the first term we need to have is this whole idea of a trophic cascade. Okay, Mustafa, we will revisit that here in just a minute as I go through this. Okay, so basically when you're talking about a trophic cascade, you are looking at the ability of a top predator to control the distribution of populations, okay, found in the lower levels, often in an indirect manner, okay? So what that's saying is that in a trophic cascade, so think about like a cascading effect. So it kind of rolls downhill. If I were to change the top, it will impact everything below it in some fashion. Now it's going to directly impact the things that are closest to it, but it is going to indirectly connect to and affect the things that are like one step away from it. So in the pyramid example where you had that guy, so if I took the top and I messed with the top, it's going to have a direct effect on that level right below it, but it'll have an indirect effect on the ones below that. Okay. Now, the reason why this is so critical is like, if you remember back in that video from the beginning of the unit, is that for the longest time, people really discredited or really didn't think about and consider all of the indirect effects, especially with regards to predators. Okay, so we saw predators as sometimes as being violent and dangerous and not really having a massive impact. And in a lot of cases, we were like, okay, well, it's going to be not really that big of a deal if we kind of take them out. What we didn't realize is that, okay, well, we knew that we expected to see and have the direct impact. That's what we expected to see. So in the case of the otter with the sea urchins, we expect to see that. What we don't expect is all of the other indirect impacts of the sea otter. That's what we were missing. So the scientists in there, when they have these aha moments, are like, oh my gosh, we did not realize, they just didn't put the pieces together in that way before. Okay, they weren't shining the light, okay, at that right angle to see that, okay, this top predator really is playing a way more crucial role in the stability of these ecosystems than we ever realized. Because for a long time, we thought that the stability of an ecosystem was based off its foundation, like its base. But what we're finding now is that a lot of it's controlled, okay, and maintained from a top-down approach, as opposed to a bottom-up approach, okay? So in this example here, we're gonna look at it a little bit deeper, okay? And I'm gonna walk you through some of these different symbols. Okay, so we're going to use the same example as we were just talking about with the sea otter, the sea urchin, and the kelp. Okay, now the symbols that we're going to be looking at are going to be either a plus or a minus symbol, or a solid arrow, or a dashed arrow. Okay, now when we're looking at those direct relationships, so one organism sits at the adjacent level, so right next to each other. You have your sea otter, then sea urchin, connected right there. We're going to use a solid line to represent that would have a direct impact. So whatever you do to that sea otter will have a direct impact on the sea urchin. Whatever you do to the sea urchin will have a direct impact on the sea otter. Okay. Now, to describe the type of impact that you're going to have on, or they have on each other, you're going to use either a positive sign or a negative sign. Now, here's where you got to go all the way back to first semester, not even just first semester, the first unit of first semester. Okay, so when we talked about homeostasis and feedback, okay, now we have this idea of positive and negative feedback. And if you recall, when we looked at positive and negative feedback was when you had an opposite response to a stimulus. So for instance, if I was hot, my body will do something to bring down my temperature, to make me colder. So if I was up, it's got to try to bring me down. If I was down, it would try to bring me up. Okay, there's this sort of inverse response that's taking place. And they will always work like this. If one goes up, the other goes down. If one goes down, the other goes up. Bing, 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 bing. Okay. You will represent that sort of relationship. Okay. So this direct relationship, you will describe that as being negative. Okay. Where negative just means they're doing the opposite. Bing, 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 bing. Okay. So in this case, if I'm going to decrease the otter population, okay, going down, then the sea urchin population will go up. So notice they're going in opposite directions, so you would use that minus sign. From there, you can then hop to the next arrow spot. So the sea urchin would then have a direct relationship on the kelp. Now, if the kelp or the sea urchin population was going up, the kelp population will then go down. Okay, notice they're in opposites again. Okay, so you would use that minus sign. So sea urchins went up, kelp went down, that they're moving opposites, so use your negative sign. However, okay, the sea otters were, near extinction here, which means that we saw that their populations were going down. And what they noticed was that when that happened, and that caused the kelp population to also decrease, we could describe this relationship. So it's kind of like skipping over the middleman. Remember, these dashed arrows represent an indirect relationship. Okay, so if we had to compare, okay, so how does the sea otter actually impact the kelp? Well, the sea otters don't eat the kelp, so they're not on the level, they're not touching the kelp. So we would have to use that dashed line. And if you decrease the otters and that cause a decrease in the kelp, okay, they're both pointing in the same direction. So you would use a positive sign. If you increase the otters, then you would increase the kelp. So they're going to work in this positive manner where both are going to go in the same direction. Okay, so let's go back to your notebook. And let's fill out some of that missing info there. All right, so solid arrows, when we're using the interactives, okay, are going to represent that there is a direct effect on a population, meaning if they're right next to each other. Now, if they're using a minus sign, if we're going to use a minus sign, that means that the opposite effect is happening between the two populations. So one will go up, the other will go down. One will go down, the other will go up. Now for your dashed, okay, your dashed arrows are going to represent an indirect effect on the population. Basically, it's like you're going to skip some levels in your comparison. So if that minus sign means that you're going to have this opposite effect, using a plus sign, okay, would show that the same impact is happening on the two populations you're comparing. One's up, the other's up. One's down, the other's down. And they work together in the same fashion. Okay. And if you guys are typing, you can also do this. You guys are feel free to cut and paste off the chat. Now remember, okay, we're talking about an ecosystem here. And what that shows you, the example that we're looking at, so otters to sea urchins and sea urchins to kelp, that is one food chain. Ecosystems are not made of one food chain. Mm-mm. Mm-mm. If they were, that's a pretty crummy ecosystem. Okay, and it's not very stable. It's gonna be outro real fast. Okay. Now, what an ecosystem is made up of, though, is many different food chains. Okay, and they're all going to overlap, and you're going to create these nice big food webs. And remember, the messier, the better. The more of a hot mess this food web looks, the stronger that ecosystem is. Okay. So when you are talking about messing with one organism in a food chain, you are also going to be starting to impact a lot of other things that you would never expect. Okay. Now, in this example, because the ecosystems are way more complex, okay, than just looking at isolated like picture, like one organism to the next to the next. Okay, remember, everything is connected. So what they looked at, though, is how does the removal of the otter impact maybe some other organisms that we wouldn't necessarily expect in this environment? So they looked at two specific ones. This, this glaucous-winged gull and the bald eagle, okay? So let's jump over to back to our interactive and see how this otter impacts those guys. Okay, this guy, if you've ever been to the beach or anywhere near the water in Washington, you've seen this lovely little creature. This is our typical seagull. Okay, they're kind of jerks and they have no fear and they like to steal your lunch. It's awesome. Okay, so these guys are common seabirds along the northwest Pacific coast of North America. They are omnivores that primarily consume fish and marine invertebrates, but they will also eat the eggs and chicks of other birds. So what happened to their diet when the otters disappeared? Notice how what they eat has really no impact. Okay, it had nothing to do with the food chain that we examined. Okay, in a direct fashion. Okay, so you don't see anything about sea otters, kelp, or sea urchins. Okay, but here's what they found is that in the years after they took out the otters, the seal's diet dramatically shifted. So where before 90% of their diet was made up of fish, after these otters left, 90% of it was then invertebrates. So we had this huge, massive swing in what they were eating. Okay, all because we took that out. Now remember, the sea otters had an indirect relationship and an impact on the kelp forest. And that's where this comes in, because that kelp forest is home to so many other creatures. So by removing that kelp forest, you are then impacting subsequent or additional food chains all over the ecosystem. Okay, just because you plucked at that otter. Okay, you plucked him out of there. All right. So how do we think this would impact something like a bald eagle? Okay. So once endangered because of human activity, bald eagles populations have recovered to the point where they are no longer classified as endangered or threatened. Bald eagles specialize in eating fish, but they are opportunistic raptors and will include small mammals as well as other birds in their diet. Okay, so notice we're including like land organisms now. Okay, this is not even just isolated to what's going on in the water. So how would the otter impact what's going on up on land as well? Now, fun fact, the bald eagle, we have, at least near my house, we have a lot of bald eagles that fly around, and we have this community page, and people post all this stuff all the time, like, oh, look out for this or look out for that. And there's also a lot of people who have those teeny tiny little like dogs, like the teeny tiny dogs, like little toy poodles and like, you know, the ones that are like teacup size. Okay. We get a lot of posts where they're like, well, the bald eagle just swooped down and snatched up my dog all the time. And they're like, get your dogs inside, get your dogs inside. They're out again. Because these guys will straight swoop, and clunk out, and off little Fluffy goes to the eagle's nest. It's savage. It's insane. Okay. So, I don't fun tangent. Just keeping you guys on your toes. Okay, so let's see. How did this impact? Now, before the otters left, okay, the bald eagle had a pretty balanced diet. So they would eat roughly nearly half and half kind of a thing, like birds, fish, and then, you know, some kind of mammals are kind of all up in there. To after the otters were absent, they primarily switched over to eating birds. Okay, their fish consumption was much lower, and mammals were even lower than that. Now, this is going to have now a much greater impact on additional neighboring ecosystems, and now we've moved the effects outside of the otter's own ecosystem. Okay, so this just goes to show you that it's not only like these effects happen within the one, but then neighboring ecosystems can start to be impacted as well. Okay, so let's go back to that last question on slide number 10. Okay, so what effect did the otters have on the gull population? Oopsie. So in this case, their diet shifts from mostly fish to mostly invertebrates. And invertebrates are organisms that don't have a vertebrae, like you have a spine and like the protective column. So think like a mollusk or like sea cucumbers. They don't have that. They're more like a squishy in texture. Those are invertebrates. You guys need to copy down those. You can cut and paste those responses into those boxes. Okay. All right. So moving forward now into our case studies, I'm going to walk you through how to complete the diagrams on slide 11 and 12. All right. So using the same symbols, okay, throughout the interactive, we're going to mimic those on slides 11 and 12. Okay. I'm going to flip over here real quick. So what you see is something similar to how it's organized in the interactive. So you guys are going to see that you have little boxes that have different organisms. So these are going to represent the populations in the ecosystem. You will then drag them into the correct spots. And this will just be as you go through the scenario or the case study, you'll just line them up. Now, the second thing that you're going to do is you're going to figure out how is that population adjusting? Is the population going up or is the population decreasing? And you're going to note the population change using these arrows. Now, I've only given you guys 2 per scenario, so you will have to cut and paste them. So to cut and paste them, remember there's a couple different ways. You guys can click on it. If you are using a mouse, then you can hit right click, copy, click out of there, right click, paste, and it'll create a new copy, and then you can just drag it to the location that you need it. Okay, so there's one way. If you are not using a mouse and you're using like a Chromebook, you can also hit Control, hold it down, and hit C, click off the object, hit Control V. Okay, so for those of you who are like, not really sure about that, okay, that's 2 different ways. You can also grab it, make sure it's highlighted, hold down the control button, click on it if you have a mouse, and drag it over, and it'll make another copy for you. So there's 3 different ways you guys can do that. Okay, so you're going to want to make multiple copies of those. Okay, and you'll need 1 for each of these, but you'll want to wait to decide which one, the up arrow or the down arrow that you'll use. Then after that, you're going to then compare the direction of those arrows to determine whether you're going to use a plus sign or a minus sign to describe that relationship. So if they're going in the same direction, both up or both down, you're going to use the plus sign. If they're going in opposite directions, then you're going to use the minus sign. Okay. So let's look at that first one together, and then I will give you the rest of the class where you can do the remaining 3. So we go over here to case studies. We're going to click on the Arctic tundra. Okay. So in this example, in addition to controlling the relative amount of primary productivity, trophic cascades can also change the landscape by altering the movement of nutrients through the community. In this example, the introduction of Arctic foxes had effects beyond the birds that they eat. Okay, so that's a huge clue right here in determining how we're going to start this guy out. So do foxes have a positive or negative effect on the seabirds? Now, to determine that, we have to figure out, okay, what is the population doing? So in this case, we're going to introduce the foxes, which means we're going to have an increase in their population. But notice that it said these guys eat the seabirds. So if I'm going to increase the amount of predators, what do you guys think that's going to do to the population of the seabirds? Are we going to increase the population or decrease the population? What do you guys think? So let me know in the chat.
Decrease.
Yeah. You add more predators in the area, your population's definitely going under. So if I increase one and I decrease the other, okay, on my notebook, I would then use those 2 arrows, one up for the fox, down for the seabird. And if they're going in opposite directions, I have that negative correlation here. Okay, so they will always operate in this manner. So if I were to decrease the foxes, then you're going to see an increase in the seabirds, and they will always work like this. Now, knowing that the seabirds are going to decrease, the interesting thing is how this fits in is that they mentioned up here about how the trophic cascades can alter the nutrients in the community. Now, the seabirds, they are going to, they are going to provide nutrients to the soil in a couple of different ways. One, if the seabirds die, their bodies are obviously going to go to the ground. Decomposers come in and it breaks them down, and it returns all of those nutrients from their body into the soil. Okay. The other thing that these seabirds provide is they poop a lot, and they poop in the soil. Nature's fertilizer. Okay. Now that's really important. Okay. So if this is the soil, okay, the other organisms in this ecosystem rely on the nutrients in the soil. And if these seabirds are providing that soil, okay, then if we decrease the birds, are they going to be increasing the amount of nutrients? Or are they going to decrease the amount of nutrients they're going to provide? Okay. In this case, definitely going to decrease. Less birds, less bird poop, less birds that are dying. So if they're both moving down and pointing in the same direction, that's where we're going to use that positive correlation. So they're going to be doing the same. If I increase the birds, I increase the soil nutrients. If I decrease the birds, I decrease the soil nutrients. Okay. Now, the soil nutrients has a direct effect on the grass. Okay. Now, these nutrients are needed by the grass to perform photosynthesis and to grow. Okay. Now, if I have a reduced amount of nutrients in my soil, okay, what do we expect is going to happen to the amount of grass? Is it going to thrive, or is it going to start to die out? So our grass is going to increase or decrease?
Increase.
So if we gave them less of their nutrients, they're going to increase? Yeah. So think about it. It's like, think like this is almost like it's not their food, but it's kind of like the ingredients to their food. It's like what they need to make their food. And if I give you less of that, the stuff that you need, you're not going to be able to do a whole lot. So by decreasing the soil nutrients, you're going to see a decrease in the grass. And then again, you're going to see both of those arrows pointing down, which means they're doing the same. So we're going to use that plus sign. Okay. So based off of just introducing these foxes to the environment, okay, what they started to notice is that there was a shift in the way that the grass looked, in the way that the terrain looked. So in decreasing the grass and introducing these foxes, you're going to see a complete system shift to where it looks like this. It's no longer luscious. All of those big grasses have completely died off, okay? Now, when you're looking at that, because the question was, how does the fox impact the grass? If we were looking at these guys in that pyramid, the fox is nowhere near the grass. Okay, on opposite ends. So we can't say that the fox had a direct relationship, like these all had a direct relationship to each other. This is a case where they would have an indirect connection. They're still part of the same food chain. However, the fox does not rely on the grass as a food source directly. So we would use that dashed line, and we would end up using this negative sign because we increase the foxes, we decrease the grass. If we were to decrease the foxes, it would flip-flop. So because they're doing the opposite of each other, they're responding in an opposite fashion, we're going to use that negative sign. Okay, so let's go ahead, let's use this information, and I will walk you through how to use that to fill out that diagram in your notebook for case study number 1. So if you notice, we have all of the organisms. Your guys' might be in a separate order because I've done this 2 times already, and so I moved them out of the way. But you're going to start with the Arctic fox. The Arctic fox is then going to eat the seabirds. The seabirds are then going to contribute some nutrients to the soil. And then that soil nutrients will be provided to the grass. Okay. Now remember, the next step we want to do is add our arrows to indicate what is happening to their population. So in introducing the foxes, we're going to see an increase. Okay. Now, if we introduce more of those fox to the Arctic tundra, we're going to ultimately see a decrease in those seabirds because the Arctic fox will eat up those seabirds. And if you have this sort of comparison right here, where they're going in opposite directions, I know that I can then swing over and put a negative sign right there, telling me that they're always going to work like that. Then I can move to my next relationship. So the seabirds with the nutrient soil. If the seabirds go down, my soil nutrients will also go down. Oopsie. Okay. And now these two, if I'm going to compare and isolate this situation, if they're both going in the same direction, I know that's a positive relationship, positive correlation. Now on to this third one. So if the soil nutrients is reduced, the grass is not going to get enough of what they need, which causes the grass population to be reduced. Again, they're going in the same direction. So I can grab one of my plus signs, drag it into the little spot, showing that these two will work together, just like the seabirds and the soil nutrients. Okay. Lastly, I can look at the indirect effect that the Arctic fox had on the grass. Because one's pointing up, the other is pointing down. That shows that opposite. Okay, so I'm going to use that minus sign. Okay, so your final product should look just like this. And you will have leftovers of your pluses and minus signs because we've just given you enough like extras. Okay, so you wouldn't have to make copies of those. You'll just always want to make copies of your arrows. Okay. Now, in the last question for each of those scenarios, you're going to want to answer the question, and it's going to be asking you to describe what's happening. So in the question 5, what indirect effect does the predator have on the soil nutrients in the ecosystem? So here to here. Okay, remember, I can say that that's an indirect effect because I'm not right next to it. So here I could almost take that dotted line and just shift it over. Okay, and how does that affect the landscape? So I might say the predator, the Arctic fox, has an indirect negative, because one's going up, one's going down, effect on the soil nutrients in the ecosystem. The introduction of the Arctic foxes also causes the reduction of the seabirds and the grasses. Okay, questions on how I filled that guy out? All right, guys, you are going to get the rest of the class period to work through the case studies 2 through 4, so 2, 3, and 4, using the interactive. And you're going to do the same thing. So you're going to read through the scenario, put the organisms in their correct spots based off of the diagram that you're working with in the interactive. Make copies of your up arrows and your down arrows to determine whether the population is going up or down, okay, based off of the scenario. And then you're going to figure out what sort of relationship that that they have, what sort of effect that relationship has. So are they working in opposites? Okay, then use the negative. If are they working together, going up to up or down down, then you use a positive sign. Okay. Tomorrow we will go through and we will correct 2, 3, and 4 to see if you guys are all on the same page. And we'll do a little bit of a review, and then you guys will have your mid-unit quiz. Okay, so make sure you guys are getting this stuff done. That way you guys are on top of it and prepared as we swing into